Hey everybody, welcome back. I didn't make a video for the graphs of logarithms. I left that in the notes. I hope you can understand those notes. I guess if it gets in a bind, I'll make one. I may just mention it in our Zoom class discussions. Okay, but in this video, I'm going to introduce the bare the bare tools that we'll need to work with logarithmic and exponential equations. It's called properties of logarithms. And I'm going to just really work with the ones that I really think are going to be the most beneficial for us in this remote setting to get our job done. There's a lot more that could be said, I'm sure, like proofs and all that stuff, but I'm probably not going to engage in a lot of that. So we're going to look at what we need to solve logarithmic equations, exponential equations. And this is like the first part of it. We have another section called laws of logarithms. And then with those combined, we'll have a complete set of tools that we can do right much with. Okay, so let's get started with this. All right, so in 2.3, it's just a bunch of rules. Okay, and I'm not going to put a bunch of examples in here. I'm going to let the video sort of be the examples, because really all you need of these notes are the rules themselves. Now, some of these may not be shocking to look at. Well, log base a of 1 is equal to 0. Well, yes, because a to the 0 power is 1. It's that circular thing we were talking about before. Log base a of a is equal to 1. We must raise a to the power of 1 to get a. Yes, a to the 1 is a. But now, these may seem like a big deal, who cares, or something like that. But when we get ready to use these to solve some equations, they do matter. I mean, you've got to know them. This is an important one. When we take the log of both sides, remember we solved exponential equations? This is one of the properties you'll use. Log base a of a to the x, look, it sort of drops that exponent down. Why? Because a to the x is a to the x. So this is one we're going to use a whole lot. This next one here is sort of an obscure property. We don't use it. I don't see myself using it all the time or anything like that. I guess you could say a base a raised to the log base a of x is x. Log base a of x is the power to which a must be raised to get x. Okay, that's a little confusing, but I think we're going to let that just lie where it is until we need it. I mean, we have to dive into it a little deeper. But I wouldn't mind mentioning a couple things about the first three properties. For the property, the first one, if you could say something like this, an example would be log base 5 of 1 is equal to 0, because 5 to the 0 is 1. That's true. All right, so the second property, we could say something like log base 5 of 5 is 1, because 5 to the 1 is 5. Absolutely true. All right, and we move down to that was actually the third one. Sorry about that. So this would be the second one here. It would say something like the log base 5 of 5 to the 10th power. Well, that's equal to 10, because 5 to the 10 is kind of silly to write, is equal to 5 to the 10. Right? 5 to that equals 5 to the 10. All right, that's just a number of examples of using those properties. All right, so let's look at another property. Now this one is a property in a way, but it's also, it just is sort of a, one of those things you just have to know, the common logarithm. All right, and the logarithm base 10 is called the common log, and it's denoted by omitting the base. Now, some people might think that's a little weird that they omit a base. Notice here it says log base, no, it doesn't have a base at all. So if you see one without a base, it's understood to be base 10. Now, I have seen textbooks where they do log base e that way, but for us, it'll always be true, okay? All right, so what we'll do is understand that if it doesn't have a base, it's log base 10. All right, here is an example of that, if you want to see something. it would look kind of like this. They could write log of 10 is 1. And you have to know that that's base 10. Or if you had to convert something to exponential form, maybe it was log base x, and log of x equals 3. Convert to exponential form. If it's written this way, you have to understand that it's base 10, and you would just write 10 to the 3 is x. Okay, that's one of those things. Now, you might find it odd that they don't, since we work in number base 10, the numbers we work with are base 10, they considered base 10 to be the common log. All right, now, do they omit notation in other areas? Yeah. If you write the number 5 on your paper, that's understood to be 5 to the 1. So we omit the 1 every time. And there's other examples of it, like when you look at the square root. Say the square root of 4 is 2. Well, they omit the index, right? This indexed with a 2 right there. And you're looking for square roots. The others aren't, right? So we often run into these things. So just realize if you see log by itself, it is base 10. For example, one more example here that's really important. It's on your calculator that way. So if I had log of 10, that is 1, right? Anyway, just that's the log button on your calculator. Change of base formula or the base change is inside here if you need a different base other than 10. Okay. All right, and let's get to the next piece of this because this video is getting long and I don't have a lot of work to do in here, just really introducing things. Now, there's another weird logarithm. I don't say weird, but they omit the base on this one too. The natural log. The natural log with base e is called the natural logarithm. Everybody abbreviates it to be natural log. I very seldom hear logarithm. And it's denoted with ln. And usually, y'all, that isn't ln in script, but in my equation editor, it doesn't pick up logs like it's supposed to. And this isn't usually script either. But I think it'll be okay with us. All right, so what does lnx mean? Well, it means it's just log base e of x. All right, where's that on the calculator? That's what I'll show you about this one. If you're working with it on the calculator, it is right there. See it right below the log button? You got ln. Now, if we put ln of e, and your e button is right there, second e, we could probably guess what that is. E to what power gives me e? Well, I think it's 1. So that's showing you its base e. All right, so that's your natural log function. Okay, see, that's just saying the same properties hold true for the natural log that we said in the, you can convert to exponential form and back and forth from logarithmic form to exponential. And finally down here, you got the same rules you had up top. I'm not going to redo those. It just says, hey, if it's got base e, then these following properties are true. Anyway, that's it for this video. You're going to need this stuff more in upcoming work when we're solving equations. And thanks for watching.